In a recent tutorial we have discussed this structure formed by a 2+2 cycloaddition reaction with an arene and an enol, and we noticed that in this case a heterolytic bond disconnection can take place, forming this stabilized cation, and on the other side this mesomerically stabilized anion. Stabilization is excellent by mesomery. On the other hand, we have a rather strained ring system, the four-membered ring. Therefore, this bond is broken easily. We can get to a neutral compound just by deprotonating here and protonating there. The hydrogen should migrate from here to there. It must not necessarily be intramolecular, it can also be intermolecularly. But what we have forgotten last time was there is another mesomeric structure, and it is also neutral. But with the aromatic system missing. It is a so-called ortho-quinonoid system. And one can also imagine protonating here, deprotonating there. Well, we come to this structure. Of course, all those are mesomeric structures. So, those ortho-quinonoid systems are highly interesting, they are highly reactive, because there are lots of reactions possible that it regains the aromaticity. Let's have two other examples. This hydrocarbon when heated up to maybe above 100 degrees will undergo an electrocyclic ring opening. To this ortho-quinonoid compound. And now a 1,5 hydrogen shift can take place. Forming an olefin here. A methyl group there. And the aromatic system is obtained again. From a preparative point of view, the following synthesis sequence is highly interesting. Benzothiophene treated with formaldehyde and dry HBr, that means HBr is introduced from the gas phase. Then a bromomethylation can take place at the heteroaromatic system. And this can take place twice. So it is a bis-bromo-methylation. If we now treat that under Finkelstein conditions, so Finkelstein reaction, this is potassium iodide in acetone, then just substitution of the bromides by the iodides take place. A bis-iodomethylene compound which easily loses molecular iodide and this ortho-quinonoid heterocycle is formed. In the presence of a dienophile, for instance naphthoquinone, then a Diels-Alder reaction will take place. The ortho-quinonoid system is trapped. And what is the product that will be formed? Six-membered ring. This one. 1, 2, 3, 4, 5 annihilated rings, 1 heterocycle, 2 carbonyl groups. Thanks for listening.